It's Mr. Formato here again with a lab video on the Lens Lab. We're going to start by taking an inventory of the materials that you need for this lab. So first of all, you need your lens. You need the candle, something to light the candle with. You'll need a piece of clay. You'll need a piece of paper, some tape, a straight edge of any kind. I've got the protractor, just needs to be a straight edge. And then a pencil. Sorry, lastly, you're going to need your measuring tape. How could I forget the measuring tape? So I want you to find a nice wide open area and lay flat your measuring tape. And then the first thing I'd like for you to do is tape the measuring tape down to the table so it's pretty secure. If you want to be able to get the tape off the table, just give yourself a little bit of an overlap on one end. So you want this guy to be taped down so that it doesn't slide around as you do the measurements. In fact, I'm gonna do two pieces just to be nice and secure. Make sure that you have the centimeter side facing up. Let me say that again. The centimeter side is the one without the big numbers, is the other side. In fact, if you look carefully at the tape measure itself, you'll see that the centimeter side has both inches and centimeters. The centimeters are the small numbers. Okay. Now, what I'm going to do is place my lens at the 50 centimeter mark. Okay, and I'm going to use my straight edge to sort of assist me in that process. So I want to take my straight edge and I just want to lay it right along the 50 centimeter mark. You can see that on my tape measure, the 50 centimeter mark is right there. And so this straight edge will basically scribe a line where the axis of the lens is going to be located. Okay, so it doesn't have to be perfect, but it should be close. So take your ball of clay, make a kind of warm it up a little bit, and then just make a flat kind of stand for your lens. You want to gently press it into the table so it's nice and solidly located, and then you want to put your lens right along that 50 centimeter line. Okay? The straight edge will help you do that. Once you have it sort of standing up, hold it in place with one hand, and then just kind of shore it up with the clay so that it's nice and stable. You can do this in a lot of different ways. Just try not to cover up the lens too much. Okay? So now that we have our lens set up and we've got our measuring tape on the centimeter side up, taped down to the desk, I'm going to switch my camera view so that you can see along the axis of the experiment. And for that, it might be a little disorienting every now and again, but I'll do my best to keep things stable. So I'm going to set this up so that I've got the candle on one side, and I've got the lens in the middle, and then on the far side, I'm going to use my piece of paper to make what I'm going to call the view screen. Now, the view screen is essentially where the image will come into focus. And I want you to make a piece of paper, fold it in half, and then just have it so you can put your hand down on it like this and slide it back and forth, okay? So you've got candle, lens, view screen, and you're going to be able to slide that back and forth. So essentially, the purpose of this experiment is to get sort of a qualitative sense of how the lens will interact with the light rays that come off of the candle. And so we've got a few very specific ways to think about this. So first of all, the lens itself has what we call a focal length. Now, the focal length was something that you determined in the first part of the video. My focal length for my lens is 10 centimeters. And so what I'm going to do is I'm just going to make a small mark on my desk at the 10 centimeter mark for the lens, And I'm gonna just make in my mind a little note that that is F. Okay, you can mark it right on the tape if you like. If you have paper and you can put it underneath your experiment, that's fine too. And if you've got a table you can make a little mark on, that's fine. Okay, but the point is that I've got my lens and then I've got a length of distance called the focal length on one side. I'm also going to mark that length on the other side. So again, if my lens was at 50, then the focal length on the other side will correspond to 40. So I'm just going to mark 40 on the tape. And I'm also going to just make a light mark on the table. So everything in this experiment is going to be referred to as locations relative to focal length. So the first place where we're going to take our candle and light it is we're going to locate the candle at a distance beyond twice the focal length. Let me say that again. We're going to take the candle and we're going to put it beyond twice the focal length. So what I mean by that is that if the focal length is 10 centimeters, the candle needs to be at least 20 centimeters away. So that's going to be back here somewhere. So on my measuring tape, that's beyond 70. So I'm going to put mine around the 80 centimeter mark, which will be, roughly 3 times the focal length away. I've used my, sorry, I was blocking the camera there. I've used my straight edge to kind of make sure that I'm doing that right. And then what I'm going to do on the other side of the experiment is I'm going to take my view screen and I'm going to slide this guy back and forth until I see an image of the candle. So allow me to take my camera here and focus in on what we're seeing at the view screen. Okay? So let's watch. Here's the lens. Here's the view screen. Okay, I think you know by now that the candle is on this side of the lens. So watch if there's anything happening at the view screen itself. Okay, can you see that little image of the candle right there? Okay. I'm sliding the view screen back and forth, and you can see that there's an image that comes into focus. Now, it's pretty bright in here. I'm going to turn off the lights, and I recommend that you turn off the lights as well in your own home so that you can get a really good sense of the image. All right, now, again, we've got the candle at pretty far away, beyond twice the focal length. I take my view screen and watch the image of the candle on the view screen. Here it is, here it is, here it goes. Look at that, nice and focused. Okay. It's a little hard to see on the camera, but your image of the candle should be crystal clear. And you want to say, okay, too close is fuzzy, too far is fuzzy. Right there at the focused image is what we call the image distance. So now the distance between the lens and this focused image, is what we call the image distance. So now we just want to make a little mental note. Where is the image located relative to the focal length on this side? If you got your image to focus, you should see that it's pretty close to the focal length. It's actually kind of right up against the focal length. Okay, now for the next part of the experiment, we're going to move the candle to 2F. Okay, I'm going to move it to exactly 2F. So for me, that's a location at the 70 centimeter mark, which is right there. Okay, so I've got a 2F distance for my between my candle and my lens. I'm going to take my view screen and I'm going to focus the candle on the view screen. Let's take a look here. All right, I have right about there. Look at that. Nicely focused image of a candle. Nicely focused. So we want to make a mental note, or maybe like an actual note, of where this thing formed. So on my setup, it seems to have moved backwards. That the place where the image formed, the image distance, has now moved a little bit farther out from the focal length, the focal point. Okay, my next experiment is going to be to move the candle to between F and 2F. So for me, I'm going to put it at 15 centimeters away, which is right in between F and 2F. And then I'm going to, again, focus the image. All right. Now, let me bring the camera up close here. We'll watch the image on the view screen as I slide it back and forth. Okay, let's see what we got. Okay, we got fuzzy, fuzzy, perfect. Now, that focused image is moving back once again. Okay, you can see that now I'm getting pretty far beyond the focal point, which is about here. Okay, so it seems like as I'm moving the candle in, that my image distance, or the place where the image forms, is moving back. Okay, now I'm going to take the candle, I'm going to put it right at F, right at the 10 centimeter line. And I'm going to try to focus an image here. Now at this point, I just want to make a really clear point here. You're not going to see an image, and it's an important observation to make, which is to say that if I take my view screen and I slide it back and back and back and back, an image never forms, and that's what we want you to observe. Okay? I keep going back and back and back, and an image never forms. That's what happens when the candle is at the focal point. All right, lastly, I'm going to move the candle within the focal point. So it's 10 centimeters, it's within the 10 centimeter mark. I have mine at 5 centimeters. And sure enough, we're going to see that an image does not form, just like in the previous example. However, you can see the image if you look through the lens. So I'm going to take my camera here, and I'm going to make it look through the lens. Okay, and I'd like to point out that what you see in there is, sorry about that, let me zoom out some. What you're seeing in the lens is a virtual image. Okay, you see that image of the candle in there? That's a virtual image. It's magnified. And in fact, that's what magnifying glasses do. They show virtual images. Okay, you can't focus those rays on the view screen because those are virtual rays and they are diverging. But that doesn't mean you can't see it. The rays appear to emanate from an image that's on this side of the lens. Okay, so for my last, the point I'd like to make here is there's a really nice sort of puzzler for you to think about. I want you to make this observation on your own. So I want you to take your candle and I want you to move it beyond F. I'm going to put mine pretty far back, about 2F or so. And then I want you to get a focused image on your screen. Okay? So you can see I've made a focused image on my screen. Now, this is one of my favorite things in all of physics. It's a demonstration that really challenges you to think carefully about what's happening with the light. The question is, what's going to happen to the image on the view screen if I cover the top half of the lens with my hand? What's going to happen to the image on the view screen if I cover the top half of the lens with my hand? Don't do it until you've made a guess. Make a guess first. After you've made a guess, you can continue to watch, and you should absolutely make this observation on your own. Okay, watch the image as I cover the top half of the lens. Sorry, I'm gonna cover it from this point of view. So I've got a nice focused image. I'm gonna come in here, and I'm gonna cover the top half of the lens. Look at that. Look at the image. How many of you said that the image was going to get cut off halfway? I know I did when I first thought about this. But sure enough, the whole image is there. In fact, the only way to get the whole image to go away is to block the very last part of the lens. Okay? If you can explain that, you will understand some pretty deep things about the nature of lenses and light rays. Thanks for watching.